Hey everyone, welcome to the Oscar3dm Podcast. Today I have Youssef Guessous of Fater AI here to talk to me about his product and all the interesting work he's doing. Um,
Hi
so,
everyone.
yeah, I'm just going to open it up by asking what is Fater AI and who is this for?
So Fater AI basically is a software that we've created for architects, engineers, all designers in a larger scope to basically be able to talk create and to basically design into the AI era. That's the main thing, the main mission that we've set up as a first, I would say, vision. And basically, the idea is to be able to control a CAD software, computer aided design, like a CAD design software, through natural language. This is basically an extrapolation of the AI paradigm applied to the architecture and more broader design industry. Basically, what we see applied in softwares, um, for example, applied to ChatGPT, applied to development coding, being able to code to achieve complex actions through natural language and description is like extrapolated to our industry. That's the main idea. The first audience that we tackle is architects. We believe that the architectural object is a complex design object that if we are able to achieve what we call talk creation into the architecture industry, being able to reproduce the architectural object through natural language, control the design, and create the architectural object through natural language, it will be very interesting and easy to apply this to broader industries. That's the main thing and the main goal.
Yeah, that makes a lot of sense. I feel like you can capture a lot of intent, through natural language. Um, it's no different than telling someone on your team, "Hey, draft this up for me. These are the design parameters. This is the intent," and then they're interpreting that and inputting it into the software, or you can do it yourself. But I feel like if this is taken to where I think it can go, natural language, there's there's a lot of powerful interpretation that can happen with that, and a lot of work steps that can get skipped. At least that's the way I interpret it, because if you say build me like a 5-story concrete building with column spacing of this and column diameter of that, you'll have a fully fledged BIM model with all the assumptions built in that um, can be made,
Yeah,
and all of a sudden you've just saved a ton of time, ton of design time. Is
yeah,
that the idea?
exactly. The first value I would say, and that's totally right, is to save time into manual, tedious tasks that we believe are destined to be automated. That the main, I would say, essence the of the human being and applied to disciplines like architecture is not on this, I would say, simple but manual and repetitive task. Is more on the idea, more on the creative side, more on the core value that cannot be reproduced into a machine.
Mhm.
That's the main thing. So being able to basically have a broader, I would say, application of the automation process, because we know also that we went from manual, like drawing, to CAD, like in basically not a few time ago, a long time ago, and now we're like transitioning with the AI paradigm to a more, I would say, broad automation into, I would say, the application of the task.
That makes a
But
lot of sense.
we'll always have this, I would say, very important role of the architect, and more broader for the human being to be able to control the machine. And you just said something very interesting that gave me this, I would say, idea. That's a challenge that we're going through, basically, is the medium of language. Like language as a medium to control a computer is something that could be like a double-sided blade. There's some challenges there, and that's what we're trying to do, to avoid like very, I would say, large like possibilities of interpretation, and to be very fine-tuned onto the application of our use case for an architect, for the language, like the medium, the sentences, the prompts to be understood well and applied with a high precision. That's the challenge that we're
Yeah,
working on.
that's a really interesting point that I wanted to get to is the trade-off between precision and speed because um,
Yeah,
you end up having to make a lot of assumptions with this kind of like generative AI. I kind of went through it recently when I was using AI workflows to make AI renderings. You can, describe generally what you want, but when you get into the very like, you can't get exactly what you want, at least out of the
yeah,
images, right? But so I'm wondering where you see this going as far as the interaction between something like a text to BIM model type of
yeah.
program. How do you take the wheel back? How do you verify assumptions? Do you think that it'll be like a kind of like a chatbot, like you say what you want, and then it'll ask clarifying questions? Hey, by the way, you didn't specify material, you didn't specify spacing. Is this okay? Is that okay? Um, and then obviously the output can be whatever you want it to be. So it'll do its best. Maybe it'll clarify, and then you can take the wheel back and verify that everything got put in the way that you wanted to. And if not, then try again. Is that like a good way to think about this?
Yeah, I would say this is it. Like there's two dimensions here. There's, I would say, the framework that we build the AI in. There's a lot of frameworks here, and we're at Fader working on a very, I would say, adapted framework, agentic framework to basically create an architecture of AIs that fine tune and refine the process of taking the input and the prompt and like think like an architect, have the process of thinking of an architect. And there's another dimension that I will go through after, which is the data set and the training. Basically, the more that your data set is formed with qualitative basically data, the more your final output will be relevant to your use case. Like basically, we have these large language models, which are base models that are very like trained on the whole internet. But for our precise need, we need to have a precise approach. So this approach of building an architecture of LLMs that refine each other in a process, an algorithmic process, basically where you have a say you have a BIM model as an output and you want to organize families, you want to organize everything into your BIM model, you would need to basically take the process, the rational process that the technician or architect BIM modeler has and reproduce it digitally.
That makes
That's the
sense. It's it does make sense because you want it to be as accurate as possible in the first shot. So you're saying
exact.
like we have off the shelf tools, but how do we refine those to be more accurate on the first prompt based on domain knowledge and thinking like an architect and not making silly mistakes. Um,
Yeah.
but uh, I think that's right. I think that's amazing. So that's like your first attempt at a prompt, but then you get something back, and how do you verify that this is actually what you want and that it didn't put something weird in the BIM data, for example?
We have a process that we just like implemented, which is called the rebound. Like basically, the AI in the backend doesn't like output one result; it outputs like a dozen of results. And the
Hmm.
idea is we have another AI that will basically measure the relevance of all the results and see with on some parameters also that we've set which result is the more adapted to the query. And after, there's also some other frameworks like reinforcement learning that make basically the user note the result and make us also get to know more what is basically searched with the first, I would say, inputs, the prompts, at which level of abstraction it applies to some actions that could be taken by the AI. Like this is something very like I want to be very precise on this. Like this paradigm of AI is very complex in a way because like it's very interesting, could be very revolutionary, but we need to be also very aware of the limits and how to tackle them. basically this is like an AI doesn't reason. An AI doesn't have a proper reasoning process, a proper chain of thought. Where like it's a replication of it. Like basically, we need to aid, basically make the model take a precise set of steps in basically our own
I see.
industry,
I
because
see what you're
it
saying.
does very complex outputs to make it relevant as an output. Yeah,
Yeah, so you have some predefined like template of things that it needs to do um, in
exactly.
order, and so it doesn't deviate from that structure. If I'm picking up what you're saying, yeah,
That's it.
yeah,
Yeah,
okay, very cool. I mean, I think it's really interesting. I've always been fascinated about text to output. I mean, when the chatbots came out, I was like a kid in a candy store. I was just,
yeah,
I couldn't believe what had happened. That you could actually have a conversation with ChatGPT. Um, and shortly after that, I maybe I have the timeline of this wrong, but around that time we also had DALI, so we had text to image, um, and then I started having the thought, well, I mean, at the core, these 3D files are can be represented through code or textually.
yeah,
So you could ask ChatGPT, "Can you make me a sphere of radius 4 as a Python
yeah,
script?"
yeah,
And output that. So I did that little experiment, and that went well. So then I was like, "Oh, okay. So you can have text to 3D, text to code." And then this was kind of the next mind blowing thing for me when I saw your demonstration of text to parametric model, because
yeah,
this is a lot of the work that I was fascinated by. And the reason why I picked up Grasshopper was the flexibility of building a 3D model from a set of variables. So the fact
yeah.
that you can set up a parametric model with those variables from a text prompt was kind of the next leap that I was really excited to see. Uh,
Yeah, and that's something like I understand, because there's, I would say, levels of generative AI, and like the thing that was missing in the industry was like I believe you saw the text to 3D to mesh models. Those basically models use diffusion, a diffusion process, a point cloud process that is not precise in its essence and doesn't think parametrically, and doesn't have this set of control that can make the model and the final output uh, 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 rightly, I would say, adjustable to a very real world set of parameters. And that's, I would say, the same assumption, and like that's what we understood to take this leap of
I
fader.
think it,
And I
it
would say,
represents like a deeper understanding of what an object is, because you can
yeah,
approximate it with a point cloud, but if you build the logic behind an object, then it
yeah,
really gets to the essence of the design, which I think is really interesting.
exactly, that's it.
Yeah. Um, so I see a lot of really rectilinear kind of applications. And I just mean that, architecture a lot of the time is straight lines at 90-degree angles with grids and
Yeah,
stuff. So you have slabs and column grids, and, those have a diameter, spacing, height. The slabs have their own dimensions. But where is the edge of the complexity for Fader AI? Like, how does it
yeah.
do with organic curves? Do you see it used in applications where the um, parameters are not so rigid? And honestly, it's okay if not, because you know architecture is a huge industry. So like there's so many applications for this in
Yeah,
architecture. So I'm just curious where the edges of this are for you.
the thing is, like, it's funny because like fader in its essence was very very practical, and like succeeded in a lot of generations related to some very complex parametric principles, like because it's an AI, an LLM that takes into account, can take any function, mathematical abstraction, and output very complex forms, very like curvy double all these kind of organic forms that you described are possible into Fader. But the challenge for us was like the other way around to make it
Oh,
practical.
that's why you were
Yeah, yeah,
giggling. You were like, "Oh, you don't even know. This was good on the complex stuff,
yeah.
but the rectilinear stuff was hard."
We
Yeah.
were very well, like we were able to create basically some very interesting and parametric forms, and like complex curvy forms that, and sometimes it's basically by describing, by inputting a script or like a basic mathematical abstraction of how we want a curve to be applied. Like I would say everything is possible into Fader. Like right now, if we use the right control, our challenge is not the output. Like I said, I don't know if I went through this, but basically we have a whole CAD library in the core of the software, and this CAD library can do basically in its essence any kind of geometrical form. That's not the problem. The problem is the control, like you said earlier. The problem for us is to redefine how we control a software, a design software in the AI era. And we know that controlling this kind of design software using just natural language, just this is not possible. Like the number of architects that think computationally are very rare. We cannot come and say, okay, everyone today will use natural language as a medium and need to define the points into an absolute. It's not possible. We need to use the AI, and that's what we're working on some very complex extrapolation of some simple visual control, keyboard mouse control, like we have in all the CAD software. So that's why we've implemented and we are still implementing some very simple and intuitive controls, like drawing a curve. I wouldn't define the curve mathematically. I would like to draw it manually. And then maybe with this curve, I would like to extrapolate it as a structure, as the basis of, I don't know, a building, as the, like we can we try to think forward of how the design process will be in the AI era,
Yeah,
and
what the
this
interface looks
becomes
like. Yeah.
exactly
Yeah.
like basically the medium of control, like talking to a computer. This is just a leap forward on how we talk and control computers and how they basically become independent on some processes that we needed to basically tell them to take some actions that
Yeah.
would
How do you get
be
it to
able
take initiative? Where should it take initiative? What assumptions should it make? If I'm
uh,
picking this up right. Because like if you draw a curve and say make me a structure, then I mean that can go in so many different directions. So it's like where how much um um, freedom should the AI have to do it? Obviously, you can. I mean, nothing is final. You can just say, okay, try again, or maybe you try to
yeah.
reprompt like you would in any other software. But I don't know. I'm fascinated with like this idea of a co-pilot. Like you throw the ball back and forth between your partner, and it tries to pick up where your intent is, and then it gives it back to you, and you know,
Yeah, this is a very good question. Like,
yeah,
what we try to do is to have this scope of actions that could be taken by the AI as large as possible and to restrict them if needed. Like,
hmm
I don't know if you know the notion of temperature. This is applied to all LLMs. The temperature basically is the more the temperature is high, the more creative and the more independent the LLM will get into the propositions. And the more it's slower, the more it will be, I would say, direct and rational about the prompt that you gave.
yeah,
So this is a first parameter that all LLMs use that, if added to the structure and the framework that I've described, can the LLM would be constrained into, I would say, a range of possible actions based on the prompt that you gave. Like it would not take some actions that are not based on what you gave. So I would say this is very, it comes very handy when, like I just described, you have an idea in mind, but you just don't know how to apply it into the software in all, I would say, the steps. We all know as architects, engineers, that we are constant learners. When we want to achieve a new kind of structure or a new kind of creation as an architect, there's always some new learnings to do. And even more, if you try to think computationally, you would basically write different scripts based on the different geometries that you want to create. So there's a thinking process, there's an effort. And this is where we want to apply the intelligence of the digital intelligence of the AI, basically, is to make us able to just have the idea, have the precise first parameters as inputs, and control this thinking process that the AI will do, the
Hmm.
hard work, basically. And
Yeah.
also will make us be able to make a creative leap forward because yeah, like the AI is basically not limited like by any of these human constraints that we could have, not limited by time, not limited by knowledge. Like you can input it in any kind of data set and make it take reproduce any kind of geometry. So this opens a very large scope of possibilities for the design world, I would say.
Yeah, that makes a lot of sense. I mean, architects, almost do they actually do studies like they're called I'm a bit I'm on the edge of the architecture world because my background is in architectural engineering and we did more of engineering coursework, but I did do like a couple design studios and worked in an architecture studio, but just through osmosis. They talk a lot about studies and interacting with the design, and really, if they want to refine a feature, it becomes a very iterative process. So
Yep,
I feel like
true.
this would be nice in some senses. This is a bit different than like a BIM workflow, but this is more like a Grasshopper Rhino workflow where you set up like a design template and you want to interrogate, certain um, certain features of the design. And so the way I've done this is, you set up a parametric model, you sit down with the architects, and then you slide sliders back and forth, and then
Exactly.
you propose A or B or anything in between, and then you tweak
But what
these.
gets
Yeah,
sorry to interrupt. What gets interesting here is imagine if the AI is the one putting the sliders and working on the
that's exactly what
sliders.
I'm saying. So the AI can build your design study. It can build your
Right?
like template, and it can help you interrogate these different ideas. So I think that that's a cool application of this as well.
And based on like abstract natural language description, like, and
Hmm.
I just want to add something that is a question we are trying to answer it, and maybe you would have some ideas regarding
Yeah.
it. But imagine you prompt basically some abstract, not mathematical, not rational, but abstract description, like make this better, make this more beautiful, make this, I would say, more harmonious. Harmony could be mathematically described, like with some ratios, like the golden ratio. You have some rational, I would say, approaches to beauty. I would say architects deal with this. Like architects have this engineer mind, but also they try also to have this aesthetic approach, and that's something that we deal with also at Fader, is to also make the model able to, in a way,
Express beauty.
understand abstract concepts that are basically not rationally, mathematically, or there's not a consensus on it. Like there's a philosophical side to this, but this is also a challenge, and I would say this applies to the whole AI paradigm. Basically, this uh, autoaggressive AI is just it's statistics, basically, just like making the word that is coming after the most likely that comes. That basically
Hmm.
that's what they do.
Yeah.
But how do we like attain a very high level of replication of the reasoning and of the human mind? And this, which is interesting with design, is design and creation is something that is purely human and purely, I would say, we are at the essence of the human being, I would say, specificity.
Yeah. That.
So we're with something that is like very interesting and that's very passionate. Like the whole team is very passionate about this subject, and we try to tackle it with the best, I would say, approach, with having a rational scientific comprehension of what we're doing, and trying to also not tackle some like false subjects, like trying to really reproduce what the AI or the machine wouldn't be able to reproduce. But we know it's a perfect replication, like it's a superficial replication that could attain a very practical use for human beings and for architects. That's the idea.
Yeah, I feel like this is a question about the limits of the technology, right? Like, can
Yeah.
an AI express beauty, and does it understand what is beautiful, and is a copy of something that it's been trained on beautiful, or is it just like a cheap copy? Um,
Yeah,
uh,
yeah. This is a question. This is a question.
yeah,
This is a
I
question
I
that
th-
I can answer.
I think this is controversial, but I think that we give ourselves a little too much credit as people. Our brains are computers, and everything is a mathematical
Right.
equation.
Yeah,
And so I think that, to your point, and I don't know much about AI, but I do understand that it's predicting the next best token, and that these concepts are mapped mathematically through a set of, like, I don't know how many parameters we're up to now. Um, but the image generators are doing this already, but it's still like in this uncanny valley where it's like I feel we're still climbing. Have you know about the uncanny valley where the more
oh, yeah,
realistic the more realistic something gets, it gets more beautiful, more aesthetic, and then as soon as it gets close to being lifelike, it drops all the way down to
yeah,
creepy, unsettling, um,
yeah. I see what. Okay.
not the real thing. It's almost there, but it's not, which really bothers people.
Yeah,
And then as you get as close as possible to reality, you start to climb back up out of this valley, all the way back until a point that's even higher than it was before it was so realistic. Um,
yeah,
so I feel like these image generators, a lot of it is falling in this uncanny valley because it's not
yeah,
quite right. The shadows are off. Some things look like
yeah,
cartoons. Hands are mangled. Faces are off. You get like bits and pieces of a painting that people can recognize, and um, it's not quite it's not quite there. So I feel like that's why I say it's a limit of the technology, because you can say beautiful, and maybe 9 times out of 10 it doesn't give you that. You have to be
yeah,
you really still have to be an artist. You have to look at it and be like, I don't think so. We have to change these details. um
yeah. The human
yeah,
control is essential, but the technology is getting like exponentially powerful through the
yeah,
years. Like I believe, like if you talk just about diffusion models, but we can apply this to Fader also because we're based on LLMs. Um, yeah, we are not even at the peak of the technology, and we see like the difference between GPT-3 and GPT-4, GPT-4o, and GPT-4 is like day and night. So we are gonna attain this like the top of the mountain that you've described, but I believe it will not be differentiable with reality. That's the thing. That's maybe an opinion, and there's it's like you said, there's a lot of technical and opinions about this, from like Ken LeCun to Sam Altman to different people in the AI world that have different views on how I would say this curve of this technology will evolve. But the idea basically is we are going into a very, very high speed of like disruption, and this replication of reality, this superficial replication will attain a level where it will definitely not be distinguishable from reality. But this will pose another question, basically, that will, and that's what we're trying also to answer to, is where is the place of the architect, of the designer, essential, that cannot be replaced and won't be replaced and won't need to be replaced because there's no interest in that. So this is a question that we're trying to address
yes.
because
For
uh,
now, the architect still needs to be the curator, because the architect is the artist, and
yeah,
is building this for people. um so it can help, but at the end of the day, it's the architect who has the vision, who makes the prompt,
yeah,
who modifies the output,
sure.
and it's their role to preserve their artistic vision. Even, it's interesting. Even when parametric modeling was a hotter topic when I was in college, people people today still don't like it, because when things are driven by mathematical equations, they end up they get too complex, because people start flexing their computational muscles and start to make crazy double waving grid shell glass
Yeah,
structures, which are impossible to maintain. But I'm trying sometimes to convince people to separate the tool from the expression of the tool, because parametric modeling is amazing and it can still make your functional, um, practical, rectangular buildings. It can also do these crazy double wave structures, and it can do everything in between. But it's just a tool, and it does extend our capabilities. But at the end of the day, it's the architect's vision and intention that's the most important.
Yeah, I think it's like an extension of basically the human intelligence. Like the first parametric approach to architecture was done by Gaudi back like in the 20th century, the end of the 20th century, on the Sagrada Familia, I believe. And that wasn't even computationally done; it was done through a model. And we know like the immense like the size of the basically this kind of projects that were done by Gaudi, and the influence it had. And I would say the outputs that could be like the what could be produced by this parametric approach is totally different in a way of what is produced with a very intuitive and direct artistic approach, which doesn't take into action into account these mathematical abstractions and controls. And I think it's just the product of our era that is more and more, I would say, we have more and more scientific means, more and more like basically technological power. And I think, as you said, this needs to be detached from the object and its expression. This is a way of attaining basically some final results. And just to finish on this, AI is taking this way another time very very far. Another time it will make us able to, which we try to do as Fader, to control and produce some very unattainable final objects, and also make it accessible to anyone, because one of the other value that we bring is we totally break and get rid of the learning curve to produce any kind of geometry. And you can see this process applied also to programming. Today you can use ChatGPT to code without really knowing how to code, and that's something that I think will be applied to the whole all our industries, where we won't need to have all these core technical profound skills to produce very qualitative results, and this will leave a very large place to the real value that we
The
have
real
on our
creativity.
exactly.
Yeah, yeah. That this opens the door for creatives who are not technical, which is kind of the opposite of who I am. But it's funny because I'm the most excited about it. Is that
Yeah,
people who don't know how or don't care to get into technicalities of software and that kind of thing, but have a vision, can execute on that vision.
yeah.
Even easier in this era. Um, so I think that's really exciting. So I was reading through your LinkedIn bio, and I have no context about your career, but I did think it was really interesting that you started as a music label director,
Yeah.
took a couple roles in between, became a project manager, and then had the idea of Fater AI. So I was just curious what your journey has looked like through these years and how you ended up here as a CEO of your company.
Yeah, basically when I was 18, I started like uh being a producer in a music label with like some of my friends. That was very casual but very interesting. It was an experience that gave me a lot of, I would say, richness regarding this very free approach which we can have to music. And I would say there's a link between the musical approach, which is could be mathematical also, and what I'm trying to do right now. So I see a direct link. I've been mentored by a very interesting and leading architect here in Morocco, because I'm from Morocco. I
Mm-hmm.
did my studies in Paris. And yeah, basically gave me a lot of energy and a lot of, I would say, confidence about what is this field. And I've basically went through a lot of steps and a lot of I would say sides about the architecture field, from I would say, the pure financial, rational, I would say, promoting real estate side, because he was a promoter, and
Mm,
also the more creative side, because then I've worked on a museum here of the Delhi Museum
yeah.
here in Marrakesh,
I mean, that's also like
which
the music industry, no? Is very there's the business side and then there's the creatives and then there's everything in between. It seems like you kind of have straddled that line before
exactly.
then and then now in the world of architecture and engineering and construction.
And I think also related to architecture, there's a very interesting characteristic about this field. Is It's the perfect bond between, like, it's the middle between technique and art. Basically, it's how we build, basically, but there is a creative side and an artistic side to it. So I always had this double mind of having a vision, having an intuition that is not rational, and having also a set of skills that are purely technical, that I try to use to rationalize a feeling. That's my journey, basically, where I went through basically this music industry and then into pure architectural field, and then I've worked in Paris in a very large firm, which is Triptych, as a project manager, where this was where I basically developed all the AI, I would say, tools. The AI tools I started to develop myself to basically automate processes in my experience. And
Yeah.
that's where I had this idea, because the first thing, and as I told you, the intuition came before the rationalization. Like, I just, when I understood the level of transformation, what is basically the AI paradigm, I had the direct intuition that 3D modeling will be automated. That's it. Like, that was a deduction that was direct. And then, yeah, to make it happen, that was there were a lot of steps. Like, I started by getting associated with my first associate, Yassine Zaidi, to basically start iterating. We created a lot of tools before arriving to the evidence of what we call machine automated learning, talk curation. We've developed like diffusion models. We've built also some text to the images renderings. We've built LLMs regarding the urban basically regulatory data in France, and that was useful. But that wasn't it. Like, we've tried to do a lot of things, but this iterative process, when you try to achieve a vision, I would say, is the mean and the best mean to know and build your, I would say, the perfect path to attain the answer that you want to give to a market and to an industry, as a need that you have into it, like, that you have experienced, like, as I have experienced it in my basically working years. And that was the leap, was in February, where we've built the first model of Fader, and we basically knew that code generation was the answer to this, like you said earlier, this framework that could be applied to think a 3D object three-dimensionally, that wasn't point cloud, that wasn't meshes. Code generation that is then displayed onto 3D was
Hmm.
the answer. If I can sum it up, I had a very, I would say, explorative first years, where I've tried a lot of things. I've saw a lot of things. I've also developed a very philosophical approach to the creative, to creation, basically, because Fader means the creator. That's the name, which is in Arabic. Fader is just a transliteration in English of the term Fater, which is a term in Arabic that means the creator. So
Mm.
the idea was to tackle creation as a process. And this, basically, what we're building right now, we think it's the first step to a much broader set of milestones to attain machine automated design. And the first milestone that we're trying to attain is to answer to two things: control and accuracy. These two, I would say, levels of development that we have are the most essential. And if you you can see also that this applies to the whole AI realm. But it's more and more important in the precise use cases that we have, because the object that we treat with is very complex, and the architects needs precise geometrical answers.
Hmm.
That's why until now they've dealt with diffusion mid-journey like models that are not geometrically precise, and the, I would say, AI wave didn't disrupt yet the architecture and design industry.
Because the
And
precision needs are too high. Yeah.
exactly, because we it's not like, it's not basically, it's not assets that we've built. Like, you can use diffusion models to build 3D assets or to have some renderings to present into the ideation process to your client. But if you want to use it in your day-to-day process and integrate it into Rhino, like we have an integration into Rhino and Grasshopper right now, we're working on with Revit, you need to basically build an interoperability between these softwares, and the object needs to be readable and integrated as a geometrical recognizable 3D model into all these softwares. And last thing about this, which is very important, we're not aiming to replace any of these current workflows. We aim to create, and we think that it is just totally new way of designing. Like, this is not a tentative to replace any way of designing. We aim to come with something really new that is with its values, with the values that I've described, and that could be basically very, very useful once we attain some very important levels. Because for now, we make the architect able to integrate its existing models to automate the process of edition. But in a further, which is very useful right now, but in a further level, that's what we're working on right now, you'd be able to, from scratch, create any kind of geometry using natural language and the new front-end commands that we have built. So this is where we're heading, and we believe this will be like evident. This is something that is evident in the evolution the technology applied to our industry, and our goal is to do it and to make it happen. That's the idea.
Yeah, that makes sense. It feels like you want to you want to be a part of everyone's workflow. You don't want to displace any like specific tool or change the way people do things. But I suppose it would change because it's a new tool in the tool set. But it seems like you want to be able to basically interact with all the tools that architects use today, which is Rhino, Grasshopper, Revit. The way I understand your technology is you've built a framework expanding on the tools available so that you can reliably and precisely build a 3D model from a text input or parametric model. Um, and then, but that's through uh, an LLM and expressed through code, but rendered online on your platform. And
Yeah,
theoretically, you could take that format, which I don't know what it is. Is it a proprietary format or is it?
we have we have like all possibly we could have any CAD formats. For now, we have GLB, we have step files,
But what is it? What
and
is
we
it
also,
programmed into?
yeah, we like the code that is generated.
Yeah,
I mean,
exactly.
it is a proprietary format
I
that
see.
we've built. Like, we had an open source CAD library that we have transformed and adapted to our LLM.
I see. Okay. And then you'll just make basically converters from that format into every other format.
Exactly.
Yeah.
Exactly. We've built parsers basically.
Yeah.
Also, to be able to input Grasshopper files into our format, we are finishing a parser that basically take all the components that exist in Grasshopper and translate them into our language.
Hmm. Yeah, no, that makes a lot of sense. I mean, I'm really into it. I love interoperability. I love introducing new workflows, and I love the idea of um, rapidly building up
Yeah.
um, a base model for the rest of your work. And really, I guess that's the way I've thought of it as like a first step to build up something quickly, which you can then refine using manual methods. But maybe that's not the vision you have. Maybe you see it as like you import a model that you've already built and you can build on top of it, or you can take it from conception to documentation. Where do you see this fitting into architects' workflows?
So the first level of integration and interoperability is applied to the ideation process when an
Yeah.
architect comes with a first idea with a client. He has a program, he has some constraints. Fader would be able and is already able to take as an input the description as a CSV file or as a textual description of the program and of the constraints, and also has an outline which defines the external terrain plot of the generation, and then makes based on a precise input the generation of the building. But the difference that we're trying also to achieve is to have a very plastic approach, a massing approach that could be like, because we're building a CAD engine, that's what we're trying to do. All the possible commands and transformations are applicable, because you will see that there's some tools that exist today that have this approach of having a plot and using generative algorithms to make this plot generated, but they are very limited in the set of possibilities, geometrical possibilities that they could produce. But we have like a CAD engine that could produce any kind of geometry as and all the levels of precision. And then what we envision is to go forward into the execution process before, I would say, the construction of the architecture. We want then to be able to, we didn't deploy our Revit integration yet, we're working on it, to make the what has been generated integrated as a Revit object, like not an external object that will be identified with all I would say the information that are needed to make it work into an execution level, which is not just a massing that is abstract, but is basically advanced in a way. And the idea also is to have it synced in all this, like I described. You come with an idea, you could try to build it into Rhino or SketchUp, a 3D model, traditional 3D model software. But Fader would serve to be synced with what you have right now, and to leap with what you're working on, maybe on Rhino, with a prompt approach, an automated edition approach, and basically to continue this execution and this modeling into softwares, BIM softwares like Revit or ArchiCAD. This is something that we're working on. We are like experimenting with some firms that we're working with, how this could be applied. Maybe in the future we will just understand that, and there's a chance to that this could happen, that Fader basically in his core could be able to get rid of, I would say, the first steps that I said, and that's what we're like heading to, I believe. Just you can model anything on Fader. That's what
Mm-hmm.
we're going to, and I believe that the Revit and execution process, all the BIM, I would say, very complex approaches that deal with some very precise parameters, would still be important, and the interoperability would happen there. But for now, we're trying to integrate very seamlessly and progressively into the workflows of the architects without trying to pretend something else. Like, we know that for now, this is very new. This is not something that is habitual in a design approach.
Mm-hmm.
So we need to stay integrated in a way that makes the industry know us more, and maybe in the future be able to answer to all the needs in a comprehensive way.
That makes sense. What kind of feedback are you getting from from your users right now, and what kind of work do they do? Are they architects for the most part?
Yeah, architects. We have for now some basic users. Like, we have three plans. We have like more than 400 users right now on our basic plan, that basically try come and use the software without forcibly talking to us. It's just a SaaS software, a SaaS approach, and basically we can like see the generations, and we hop on some calls with some of these basic users. So some of them come by curiosity, because it's something that basically is very interesting when you say basically to prompt 3D models into creation.
Mm-hmm.
And this is the first level. The second level is where they start to understand how this could be useful for their current workflows. The challenge that they deal with right now is the control, because we can say that the natural language is something that is accessible to everyone, but yeah, for now, if you have just the natural language, you need to really think computationally to make what you want to do into Fader. That's why we've integrated, based on the feedback that we've received, manual commands. So that's the first thing. A second level is the enterprise plan, where we work with very large firms that have, I would say, their proper data set, their proper workflows, and we fine tune the model for them. We
Mm,
make Fader adapted to their workflows and to their, I would say, precise geometrical needs, and we train it for their data sets. And here we have a way more interesting, I would say, interaction with the industry, because we get a lot of feedback. We create a lot of value, because we basically bring more than just a general model. We bring a very precise adapted model to them. So this, what we have right now, is very useful when it is adapted, and that's the power of AI, is the dimension of fine tuning. So we have these two approaches, but we believe that the more data we gather and the more, I would say, development we get. We didn't fundraise yet, like we've totally bootstrapped. So we've done this by our means, and we've just launched like 2 months ago. So with the means that we have, and we're like currently fundraising, we'll get a, I would say, an exponential, I would say, a development on the basic side, that I said, the from scratch approach. Like anyone could get into Fader, and not really know how to think computationally, just prompt naturally, and we are building an interface uh, um, uh, that is like very similar to what we know as a CAD software, and
mhm.
we are trying to make it easy to come and, without fine tuning, without knowing how to think computationally, create anything. And that's our challenge, and that's where we're heading to. I would say the basic plan that is just based on for individuals, basically, for B2C, B2 Pro, basically. Yeah.
Yeah. So, do you see this as being like a standalone desktop application with your own interface in the future, or do you want to plug in? For now, I know you said you want to plug into the current ecosystem, but it sounds like, if you want to build everything front to back and you're building out the infrastructure for commands, it seems like if it gets traction, that you could make this a standalone desktop application. Um,
Yeah. Yeah, for now we are a standalone, like web app.
Web app, yeah.
With Yeah, we like aim to get more and more independent, and that's, I would say, the interest of any software, is to just be comprehensive in its approach, in, I would say, the ideation process, like I said, and the goal is to just give the place for a new way of approaching the design process. So yeah, totally, we are a standalone application, and
Yeah.
we'll get progressively more independent in our process.
Yeah, that makes sense. Um, I come from the Grasshopper world, so when you were talking, I was like, how would I implement this in Grasshopper? Um, and you can tell me if this is a good or bad idea, but you basically have the Fader engine with all the prompting capabilities, and you have basically all your inputs into a Fader component. Um, and then you run the algorithm, it makes it in your proprietary format, and then executes the parser to create all the components on the Grasshopper canvas. Um,
Exactly,
and
exactly.
and and then you have a Grasshopper model, but people don't have to leave their the comfort of their Grasshopper canvas to go type in Fater AI. They can just download the plugin, drop it on the
Yeah,
canvas whenever they want something quick, and then try it in their workflow. Because honestly, that's probably like if I were to adopt it in mind, that would be the dream for me. Like, well, okay, I could quickly build out a column, grid, and a couple of floors. I'll go ahead and try the Fader tool. Let's see if it can do it. And I just type it in and see how it does with the script that I was going to spend maybe 10 minutes on. Um,
yeah.
yeah,
Yeah, that's totally possible. Like
yeah,
what we're finishing the parser that will make this totally possible on all the components, because there's 800, I believe, components in Grasshopper. A good set of these components are not very used by everyone. There's, I would say, 20% of these components that are the most used ones. So we're starting with these ones, and
Hmm.
basically the language that we're using, like the scripts, like the process, the engine of Fader, is basically we're parsing it with Grasshopper, and it will be totally possible to control, create scripts create geometries in Fader, make them translated into scripts in Grasshopper, and the other way around. So this virtual
Hmm.
circle will be perfect. We are also adding the possibility to think nodally, like with nodes in Fader, because we think this is a process that computational designers, like visual scripting, is like something that we all know, and we are also going to implement it into Fader. So we have also this like this curve of progressively gain more and more comprehensive in our interface.
Hmm.
And we believe, like that's what we believe, that we need to give a lot of, I would say, control in Fader, and if needed, if desirable, if desired, the architect or the engineer would implement and sync its Fader model into Grasshopper to maybe transform it in another way. We don't want to limit, like we just want to have everything in Fader, but also to give the possibility to integrate with all the existing softwares, because we know, and I know as an architect, that when you learn a software and you spend like 10 years working on it, you don't want to leave it. Like it's not something that we think is even like desirable in our rent. We just believe that we will create a new submarket in this industry. That's the idea. And this, what you described, is totally possible. We're working on it. We're finishing the parcel. It will be synced in the whole, I would say, circle that I've described. For now, you can only integrate your geometry from Fader into Grasshopper. Our extension is live on foot for right now, so you can use it from now.
Yeah, that's incredible. I'll have to give it a shot and try to throw some stuff at it. But I
Yeah.
think that's a great approach, open to everything, and while it builds its own legs as well, and see what form it takes and how people want to use it. Um,
Yeah.
so it sounds like through your career you've been an artist, a technician, and I kind of want to throw in entrepreneur because that's kind of what you're doing now and what you were as a music label director. Um, so, how has that process been for you of running your own company? Is that something that you've always needed to do for yourself? Um, what what drove you to that?
Yeah. Great question. Yeah, some, I would say, an internal evidence, and I've always knew that there's a lot of, I would say, freedom in entrepreneurship, uh, in basically applying to the world what you think is good for everyone. Like this is a very, I would say, philanthropic approach that doesn't limit you in a position where you have maybe some opinions, you have maybe some desires, but you're constrained into a job that you have. That the fact that I've totally uh, like gained a lot in my I would say experiences in working in firms, but that wasn't like totally, like I did it just to gather information and to gather knowledge to do what my thing. That was the idea. And this entrepreneurial journey was totally evident from the start. I've always had an entrepreneurial mind, but in my young age, I was way more driven by my artistic side, so that allied to entrepreneurial endeavor could produce what I've done in the music industry. But once I basically gathered a interesting knowledge in the architectural industry, and my mind was always open to technology, and that was something that I knew, and I still emphasize on it, is the cornerstone of our era. Like this is what basically makes our world go and advance. And AI will be the most giant technological disruption of humanity. This was I would say, the flame that made me directly utilize what I knew about the industry, and how I believe it could be transformed for the better. So I would say entrepreneurship is a very philanthropic approach where you create value, you create good, and by creating good, you gather people around the project, you create a vision, you lead the team to a precise goal, and basically you create value and be useful. Being useful for the others is the main drive, and is also the most accomplishing mission, I would say, that anyone can take. That's why I believe that in in the entrepreneurship is, I would say, the most um, I would say, harmonious human condition, where you go directly and attain your precise vision for the world, or for a precise, very maybe limited, or some very precise need that you wanna tackle, or something which is broader. It doesn't matter. The idea is just to go for it, and not to stay into a doubt that maybe you have, like, this is something that for sure could hit, like I had, like, doubts and limiting ideas that could just saying that this is something that would, a lot of people would say this is impossible to do. A lot of people would say this is not adapted to a traditional industry, because our industry is one of the less disrupted industries. Like, historically, the industry
Hmm.
of construction is very traditional. So I've, like, listened, like, I've had a lot of critics when I started, but I didn't really listen. I've just went through, and I am very pretty happy with what we're doing right now, and I believe we will attain very soon machine automated design, which is our goal. Yeah, and entrepreneurship for me was a liberating experience. That was it.
That's really interesting. I hear a lot of similarities to what you're talking about. Um, AI for sure has given an opportunity for you know people like you to take advantage of the shifts in the world and be at the front of a lot of the change that's happening, because a lot of these tools, they haven't been thought of, they haven't been built. It's such a paradigm shift, and there's so many possibilities. It's really exciting, and it is a chance to you know uh, execute your vision in a way that someone else hasn't before. And whenever you see like that opening for yourself to step in, it's just so exciting. And it's
Yeah,
almost like you want to prove your theory of the world, or like you want to um it's like you want to be philanthropic, like you said. You want to help people, you want to leave an impact in that way. But um it's like proving that what's best, or that you have the vision for what's coming. It's I don't know how to like really articulate that, but
this
it's
is
kind
super
of like
interesting.
testing your theory. It's like a thesis statement, I think.
Exactly.
Yeah.
You're not pretending that your theory is directly true. Like, you've,
Yeah.
like, the thing that's interesting is the process, the fact that you try it, and by
Hmm.
trying it, like, the idea that I had was developed and changed by
You
the
get to
iteration.
test your ideas, and no one can tell you what exactly to do. You get to again and again put it out in the world and see whether it takes, and what you were right about and what you were wrong about. And when you are right, you get to take um
Exactly.
I don't know, you get to take the credit for that. But not I'm not driven by like external credit, but just the fact that I was able to call it right, if that makes sense.
Yeah, and if it's not right the first time, it will be the
Yeah.
second, and if second, it will be the third.
Yeah.
That's basically, just jumping into it is the most important thing,
Yeah, yeah,
I believe.
it's iteration, and
Yeah,
a lot of desire to improve the way things are done, because you see so much opportunity, you see how things
yeah.
could be better, and you really want to like make believers of that, you know?
I really believe, like, we're, yeah, totally. I really believe that we live an era of prosperity. Like, if things are done, like, if we analyze what could be bring by not only AI but robotics also. The dimension of robotics is very important, and in the future, like, we have so much opportunities to totally solve a lot of very, like, words problems. practical words problems, because AI as a whole could potentially bring a lot of value regarding the core problems that we're going through as a species, because there's basically an exponential development to it. And like, I'm not even talking about quantum and what we are could experience in the future. So I believe, and I have this belief, and I think it's totally valid, and maybe the future will show me. I'm ready to see if it's not it, but I believe that technology is just a tool, and it's how it's used, like taking the opportunity to use it for the good and to solve problems, to produce value, and to have this conscious decision to do it is the difference. The fact to let basically some other, I would say, possibilities happen that are not really advantageous for an industry or for a broader, I would say, for humanity, could be an error. Like, I believe that there are some things that could really be solved in our industry, and I take the decision to make it happen. That's basically the spirit, if I have to sum it up in a sentence.
Yeah, I think that's a great mission, and that's a great way to look at the world. It seems like a lot of people are going to get some benefit from this, so I'm excited to see how it develops. Um,
Yeah, thank you.
yeah, is there? I kind of want to wrap this up. So, is there anything else that you want to say before we finish
Yeah.
this up? Um,
I Yeah,
yeah,
I want to thank you for the opportunity to express these ideas. I really like the approach, and I believe like that you will get really far with basically your podcast. I really like the idea. I really like the approach, and I want to thank you that as a first level. And in the second level, yeah, maybe we could make another podcast in 1 year and see what had been achieved.
I would love that.
We
That'd be great.
Yeah, we're trying to really achieve this vision, and also to be useful as possible, and to, yeah, achieve the final mad vision. So thank you a lot for your time. Thank you a lot for this opportunity to express these ideas. And yeah, let's have a future discussion to maybe sum it up in the future in some other regards. Thank
Sounds
you a
great.
lot.
Yeah, I'd love to check in again and see how things have developed and what your new theories are around the business and how people can use this. So, it
Yeah,
was a really good conversation. I really enjoyed it. Um,
yeah,
yeah,
me
we'll
too.
do this again soon.
Yeah,
All right.
thank you a lot, Oscar.
Yeah, thank you,
Have a good
Youssef.
one.
Yeah.
Bye bye.